Hello everyone. Before moving on to the lesson, try this warm-up. Complete the function table and find the gap. These are both things that we talked about in the previous lesson, so if you've forgotten, you should review that before trying this. But I want you to pause the video, complete the function table, find the gap, and then check back in to see how you do. Okay, hopefully you remembered how to do this. When the input is 0, replace x with 0. Do the calculation. -5 times 0 is 0, plus 25 is 25. Then we change x is 1. -5 times 1 is -5, plus 25, that's 20. Keep going, you get these numbers. As we move from one output to the next, we are decreasing by 5 every time. So the gap is -5. Now, one thing I'd like you to notice is that the gap appears in the equation. We talked about this in the last lesson. It's the coefficient on the x variable. I want you to notice this too. This value right here, when x is 0, y is 25, and that appears here. We can think of that as the starting value when x is 0. That's the starting value in our function, or we can call it the initial value or the y-intercept. And we're going to connect these ideas in this lesson. We're going to talk about linear functions. So the root of the word linear is line. So these are functions that draw a line when you make the graph. So we are going to graph a linear function from its form, y equals mx plus b, and we're going to make an equation to represent a graph. This is the goal for this lesson. We're going to review some key concepts about graphing lines from grades 9 and 10, and we're going to apply those with function notation. First, we need to review some concepts about linear functions. There's something called the rate of change. The rate of change, or ROC for short, the rate of change is a measure of how quickly one variable changes in relation to another variable. Now, the variables we usually use are x and y. X is the input, y is the output. But the rate of change is how quickly one of those variables changes in relation to the other. We also call it the slope in application to the graph. The slope of the line on the graph is equivalent to the rate of change. Now, rate of change and slope are calculated the same way. And you might remember this from previous grades, rise over run. We use the symbol m for the slope. Slope is equal to rise over run, or we can think of rise as the change in y and run is the change in x. This is my preferred way of writing the equation for finding the slope of a line. And we can calculate slope, or the rate of change, from a table of values. Remember, slope is equal to the change in y divided by the change in x. So if I take two rows or two ordered pairs on this function and I find the change in y and the change in x, I can then use those values to calculate the slope. The change in y is 9, the change in x is 6, so 9 divided by 6 in lowest terms is 3 divided by 2. As a fraction, we can turn that into the decimal equivalent, and either are fine. So the slope, or the rate of change of this function, is 1.5. The fraction form is actually more useful for when we are making a graph, but we'll get to that. Now, we can also calculate slope from a graph. So here is a graph of a linear function, and I want to calculate slope, which is rise over run, or change in y divided by change in x. So what I have to do is I just have to find 2 points on the linear function here. And the points that are easiest to find are the ones that are right on the intersection of two grid lines. So here's a point, and here's another point. So if we use those 2 points, we can find the rise and the run, the change in y, the change in x, and we can find the slope. So for this line, from one point to the next, we're going down 3, right 2. So the slope is -3 over 2, or as a decimal equivalent, -1.5. Now let's put this all together. We can take an equation and turn that into a table of values like we did in the warm-up. We can find the gap, the change in y. We can find the change in x. And we can use those numbers to calculate the slope. We can also take this table of values and plot points on a graph, and we can find the slope using rise over run. And it ends up being the same. Rise is -5, run is 1. -5 divided by 1 is -5. Either way you look at it, whether you're finding the slope using the gaps in the table of values or you're using the rise and run on the graph, you get the same slope value. And just a reminder, that slope value can be found in the equation. It's the coefficient on the x variable. The other thing, if you look on the graph, where does it cross the y-axis? That's called the y-intercept. It's the point on the y-axis. Think about what your x value is at that point. It's 0. So there it is on the table of values. When x is 0, y is 25. And we see that right here in the equation. It's the constant in the equation. So we can tell from the graph, from the table of values, or from the equation itself that our y-intercept is 25 here. And I just want you to be comfortable with all these connections. Equation tells you the y-intercept and the slope. The table of values tells you the y-intercept, and you can figure out the slope. The graph, you can see the y-intercept. You can figure out the slope. You can tell, because I keep repeating myself, that slope and y-intercept are very important things to know when it comes to understanding linear functions. Now, the general format for the equation of a line looks like this. Y equals mx plus b. And we've already talked about m is the symbol for slope, and b is going to be the symbol for the y-intercept. So that's what those symbols in the equation mean. So when you have a function and you find the slope, put it here. It's now the coefficient on the x variable. And when you find the y-intercept, put it here. It's now the constant in your equation. If you know the slope and the y-intercept, you can then determine the equation of the line. So just remember, y-intercept is where the line crosses the y-axis. And the slope is rise over run. So here's an example that you can try to work out. Write an equation to model the linear function f of x. So here we have an input-output table. You can use the table to find the slope and the y-intercept, and once you know those two things, you can figure out what the equation of f of x is. So pause the video and see if you can come up with the equation of this function, and then check back in to see how you do. Well, the first thing I'm going to do is find the slope. So I picked 2 rows on my table. I found the change in y, I found the change in x, and I used those numbers to find the slope is -2. So if I update my equation, I know it's going to be mx plus b. M is the slope. I know it's -2. So now I have f of x equals -2x plus b. I still don't know what b is. It's the y-intercept, and I can find that when x is 0, y is 30. So I know b is 30. So when I update my equation, I have f of x equals -2x plus 30. So that equation represents the function pictured in this table. I got it by finding the slope and the y-intercept. Now this is the same thing. We want to write an equation to model the linear function f of x. This time though, you have the graph of the function, not a table of values. But you can find the equation of this line the same way. So I'm going to ask you to pause the video, see if you can find the equation of this line, and then check back in to see how you did. Well, here we are. The y-intercept is 2. From one point to the next, you're going over 4 up 1, so the change in y is 1. The change in x is 4. The slope is 1 over 4. So the function is f of x equals 1 over 4 x plus 2. Now this example is a little bit different. This time I'm giving you the function equation, and I want you to make the graph. Remember what the different numbers in the equation represent. One of them is the slope, one of them is the y-intercept. If you know those two pieces of information, you can figure out how to draw this line. So why don't you pause the video and try this to see how you do. First, I noticed that the y-intercept is -3, so I plotted that on the grid. Next, I noticed the slope is 1 over 2. Rise of 1, run of 2. That means up 1, right 2. So from that point I just plotted, the y-intercept, I'm going to go up 1, right 2. Plot another point. Do it again. Up 1, right 2. Plot another point. Do it again. And you keep that process going. Up 1 over 2, up 1 over 2. Now to work backwards, just do the opposite. Down 1, left 2. So down 1, left 2, down 1, left 2, down 1, left 2, etc. And you can keep that pattern going. Draw a line through the points, and there you have your function. So I got that from starting with the y-intercept, my initial value. It's on the y-axis. Then I used my slope to find other points, and I drew a line through them. One final thing about graphing for now is that if this pattern just keeps going in either direction, indicate that by putting arrowheads on the ends of the lines. All right, here's a challenge problem. Write a linear equation to represent the relationship between heart rate and age. So here's heart rate, here's age. You do have enough information to find the slope and the y-intercept and to make that into an equation. So if you're up for the challenge, you can pause the video now and see if you can do this. Here's what I did. I found the slope the normal way. Change in y, change in x. Slope is -15 over 25. And I just put that in the lowest terms, -3 over 5. Now I didn't know what the y-intercept is because it's not given to me. I know when x is 0, I get my y-intercept of b, but I'm not told what that is. So I actually have to do a little bit of work to figure that out, and that's what I did over here. I knew the slope was -3 over 5, and I also knew that when x is 20, y is 138. So the function has a value of 138 when x is 20. -3 times 20, divide by 5, that's -12. So if -12 plus b is equal to 138, then do the opposite. 138 plus 12 is what b is. So that means b is 150. So think back here. When I go back to age 0, that means the heart rate goes back to 150. So now that I know my slope and my y-intercept, I know the function equation is this. And now it's time to practice. You can put together all these things we talked about: slope, y-intercept, and how that relates to a table of values, an equation, a graph, and we did some work with that. So you'll be practicing that, and if you run into any issues, please let me know.